Okay, my dear friends. Now in the previous part you have understood that we have proved on the basis of diagram that the energy level of 2 sigma is equal to 3 sigma, and that proves that the bond angle is 60 degree and it is a equilateral triangular geometry. Up next thing is we go into the molecular orbital diagram and Walsh correlation diagram. This is the only part remaining now. So pehle we go into the molecular orbital diagram. In the molecular orbital diagram I'll show both of them, that is linear as well as the triangular one. Linear and triangular. Both of them are with respect to the energy. So on one side we have the central atom, that is HB, exactly on the same side. Okay, आप please scale का इस्तेमाल कीजिएगा so that you come to know exactly at what level it is, HA and HC, and at the center we have H3 plus. Okay, why they are at the same level? Because they are of the same elements. So electronegativity value is same. So the energy level is also same. Okay? Now, when we talk about HA and HC, okay, we are going to show you two of them. And I'm going to show this bracket, so you understand this very well. या फिर आप क्या करो, दोनों को बाजू बाजू में भी दिखा सकते हो, no problems with that. And this is like this. Okay? Now this is 1s, these are also 1s. Now all these combines and it results in the formation of first, next is the second, and then we have the third. Like this. Bonding, non-bonding, anti-bonding. Non-bonding, no change in the energy, और वो non-bonding था किसका? Peripheral atoms का था non-bonding. ठीक है? Now the electrons to be adjusted. How to adjust the electrons? That is more important. This is H3 नहीं है दोस्तों, it is H3 plus. So it's a positive charge. So that means one electron is less. Okay, so total there are 3 electrons of 3 hydrogen. But in this molecular ion, I need to show 2 electrons. So the question is, कौन सा ऐसा HA, HB, HC में से कौन सा ऐसा atom है जिसके पास इलेक्ट्रॉन नहीं होगा? तो very simple, and that is, this is not an ordinary type of a compound, it's a complex ion. और in a complex हमेशा याद रखिएगा, the central atom has the ability to accept electron. You know this very well. Metal, ligands, coordination chemistry. Okay, these are basics. You know this. So whenever a metal is going to be at the center, it has a tendency to accept electron. And why it accepts electron? Because its orbital is vacant. Okay, ये ज़रूरी है दोस्तों. There has to be vacancy in the orbital, then only the electrons can be accepted. और वही यहाँ पर follow करो. आपके पास सामने आंसर मौजूद हो गया. Okay, हमारा क्वेश्चन क्या था दोस्तों? कि out of HA, HB and HC, which one is a vacant orbital? So the one which is at the center, okay, is going to be vacant. Okay, और center कौन है दोस्तों? Yes, HB. So you show HB as vacant. Okay, और HA और HC में एक single electron दिखाओ. Now in the molecular part, when you need to show the electrons, you know it very well. The rule is very clear. The electron occupation starts from the lower energy, and from lower energy we go to the higher energy. And next more rule is, electrons will not go to the higher level till the previous lower level is completely filled. Okay? यहाँ पे कोई एडिकेटिव सिस्टम नहीं है. Okay? जब तक 10th के सारे सब्जेक्ट्स पास नहीं होते आप 11th में एडमिशन नहीं ले सकते. वैसे यहाँ पर भी है. So as a result of which ये दोनों इलेक्ट्रॉन्स यहाँ पर पेयर हो जाएंगे. Okay? So this is, you know very well, whatever the denotations which was given, symbol was 1 sigma, 2 sigma and 3 sigma, and therefore the electronic configuration we say it is 1 sigma square. Okay, and the molecule is dimagnetic because all the electrons are paired. Okay, understood this? This is the molecular orbital diagram for a linear configuration. Now we go for the triangular configuration. Triangular configuration mein, what we need to do is, yes, simple part is, we show 1 sigma over here. As usual, HB is on one side, HA and HC are on the other side. So that on the same straight line you show it, or you show it by means of brackets. This way, 1s, 1s, At the center we have NH3 plus. Okay, so now how we need to consider is, first combination is this. Okay, and the second combination I am going to show it this way. Okay, there are only two levels, you know this very well. Okay, in case of triangular, now this will be one orbital over here, this is 1 sigma, and then I prove that 2 sigma is equal to 3 sigma. So there are two orbitals having the same energy, and this level if you see, and if you match with this, you come to know that this has a lower energy level because this is all with respect to energy. So in the triangular configuration, this is the triangular configuration, this is the linear configuration. So in the triangular configuration, the highest energy level is having a low energy as compared to that of the linear, and therefore we say the triangular configuration is more stable. Okay, ये मैंने आपको पहले भी prove किया, ये diagram से भी prove हो जाता है. Okay, now the electron part, you know this very well. One electron, this is vacant. Okay, and then 2 electrons over here. Only now, my dear friends, थोड़ा symbols में change करना है. We are not going to use 1 sigma, 2 sigma, 3 sigma. According to symmetry, the terms that we give are A, this is single non-degenerate. Next is T for triply degenerate, and E for doubly degenerate. Okay, these are the three symbols. Okay, A single है, non degenerate. Degenerate मतलब क्या? Energy level same. अभी एक ही है तो फिर obviously वो same हम लोग बोल ही नहीं सकते because same के लिए there has to be at least 2. Okay, so we say it is non degenerate. Triply degenerate मतलब there are 3 orbitals having same energy. Doubly degenerate means there are 2 orbitals having same energy. Okay, so this is for what? A non-linear system. Okay, we are going to use this symbol. That means we are using the symbol for this. Okay, तो कौन सा use करेंगे अभी symbol? Yes. Okay, this one will be A because single है, and this one will be E. Understood this? Okay, and therefore the electronic configuration will become what? A square. A as well as E. This is doubly degenerate. This is single non-degenerate. So both the electrons will occupy the lower A. So it is A square. Understood this part? Everybody? Okay? So this is about the molecular orbital diagram with respect to both the linear as well as the triangular one, and it's very clear from the diagram also the triangular configuration is more stable than the linear. I hope you have understood this very well. Yes, my dear friends, in the previous section I have explained to you about the molecular orbital diagram of H3 plus in both the configurations, linear as well as triangular, and then we proved it that the triangular configuration is more stable. Right? Now, the last point that is remaining, and that is about the Walsh correlation diagram. It's a diagram between the energy of the molecular orbital and the bond angle. Alright, so it's a very simple diagram. If everybody has seen the previous part of this particular trihydrogen molecular ion, you understand this very easily. Okay, it's with respect to what? Energy levels of the molecular orbital, and this is going to be the bond angle. On one side I am going to show 180 degree, on the other side I am going to show 60 degree. You can show 180 over here, 60 over here, it's your choice. Okay, so 180 degree and 60 degree, this is what we are going to show. This is according to SALC and this is experimental results. So 180 degree, from the molecular orbital diagram you can recap, there are 3 levels, yes. The first level is 1 sigma, the second level we have is 2 sigma, and the third level we have is 3 sigma. In 60 degree, in the triangular geometry we have got only 2 levels, A and E. Yaad hai na? Yes, it is A and E. So as we go from 180 degree to 60 degree, slight decrease in the energy level, slight decrease, and that gives you A, because the 3 hydrogen atoms comes much more closer there is a close association of the 3 hydrogen atoms in the triangular configuration as compared to the linear configuration. Linear में HA and HB are in contact with each other. HB and HC are in contact with each other. लेकिन HA and HC are not in contact with each other. लेकिन triangular में all the 3 are in contact with each other. ठीक है? So that is why we are going to show this. Okay, next is, you know very well. Now we show a line over here that is at the level, that is E. So 2 sigma, the energy level is slightly raised. I prove this. 3 sigma, the energy level is lowered. Okay, so I can show it once again to you so that you understand this very well. 3 sigma, I join it this way. 2 sigma, I join it this way. So you can see this 3 sigma energy is lower, 2 sigma the energy level is raised, and it comes to E. E is the highest energy molecular orbital in a triangular configuration. And this is a linear configuration where 3 sigma is the highest. You compare 3 sigma and E and you come to know that the energy level of E is lower as compared to 3 sigma. Energy level is lower and therefore we say it is stable. So the triangular configuration is more stable. Alright, now one more thing is, as I told you, the electronic configuration is A square. Now the A molecular orbital is delocalized. ओके, delocalized नाम से पता चलता है ना आप लोगों को, एक जगह पर वो सीमित नहीं है, वो delocalized है over all the 3 species, all the 3 hydrogen species में वो घूमता रहता है, वो एक जगह पर स्थित नहीं है. और उस मॉलिक्यूलर ऑर्बिटल में जो इलेक्ट्रॉन है वो भी delocalized होंगे फिर. ओके, अगर सपोज ये जो मार्कर का जो टॉप है वो मैंने मेरे हाथ में रख दिया ऐसा, ठीक है, और मैं मेरे हाथ को एक जगह से दूसरी जगह लेके जा रहा हूँ, तो ऑब्वियसली उसके अंदर का जो टॉप है मार्कर का वो भी एक जगह से दूसरी जगह जाएगा. सेम थिंग इज ओवर हियर. अगर मॉलिक्यूलर ऑर्बिटल इज डीलोकलाइज्ड तो उसके अंदर के जो 2 इलेक्ट्रॉन्स है वो भी डीलोकलाइज्ड है ओवर ऑल द 3 हाइड्रोजन एटम्स. ओके, और इसका मतलब ये हो गया कि यहाँ पर जो बॉन्ड है दैट विल बी कंसिडर्ड एज 3 सेंटर 2 इलेक्ट्रॉन बॉन्ड. इसको ऐसा नाम दिया जाएगा. It will be called as what? 3 center 2 electron bond. Okay, and it will be denoted like this. ऐसा दिखाएंगे हम, H H H and the overall charge is plus. This is H3 plus. Okay, तो ये आपको याद रखना है. The A molecular orbital is delocalized over all the 3 hydrogen species. And therefore the 2 electrons which are present are also delocalized. They are not localized between the 2 hydrogen only. Okay, and therefore I call this as a 3 center 2 electron bond. Okay, in terms of S3 plus, this is what the arrangement is with a positive charge, and this is what is called as a trihydrogen molecular ion. Okay, and I hope that from my side I have tried my level best to make you understand completely the bonding in trihydrogen molecular ion. I hope all of you have understood this. Thank you very much for being with me, and yes, please do subscribe my channel so as to get the updates about the new molecular description. Okay, so thank you so much.